All right, we're going to be doing systems of equations still in chapter 6, but we're going to be focusing on mixture problems right now. So your directions are define variables, write a systems of equations, solve, and then of course write your answer in a complete sentence. Now for this lesson, I am only going to show you how to define a variable to set up. We can talk about how to solve it, but I'm not actually going to take the time to go through and solve all of them. You will be able to solve these either by elimination or substitution. It'll be completely up to you and what you're most comfortable with. So let's go ahead and take a look here at number 1. So on number 1, it says how many liters of 15% acid and 33% acid should be mixed to make 40 liters of 21% acid solution. Okay, so for those of you who are visual people, I'm going to kind of give you a picture here. What we've got is like a container, tub, bowl, whatever you want to call it. And it says we're going to be putting 15% in, and we're going to be putting in 33%. And when I put these in together, that's going to give me a total of 21%. And at that 21%, I'm going to have 40 liters. So I'm going to go ahead and put in here 40 L for liters. Okay, so that's kind of what the general gist of what's going on here. So now I'm going to go ahead and define my variable. And the question is, how many liters of 15? So look right here, how many liters of 15 and 33? So I'm going to put X equals amount of 15%, and I guess you could have put liters if you wanted to put liters, and Y is amount of the 33%. Okay, so now just like earlier in this chapter, we talked about how money always stays together. Well, it's the same thing. Your percentages will stay together. All right, so we're going to kind of look here then. We have a total of 40 liters, and our liters will stay together. So remember me talking about how I should have maybe put this as liters? Okay, so when I'm talking about the blue here, the blue 40, I've got the 15% and the 33%. I've got both those liters giving me a total of 40 liters. So I have liters all being mixed in together. Now I'm going to look at my red equation, and this is where I'm going to be putting the percentages. So I've got 15%. Instead of 15, we're going to use 0.15 X plus my 33%, and I'm going to get a total, again, what's in here? I'm going to get a total of 21%. Now notice how that I'm multiplying 15% by X, which is X is our liters. So I've got 0.15 X, 0.33 Y, which again is liters. So I've got 0.21. I'm missing a liter out over here. And so if I come back up here and look, I know that at 21% I had 40 liters. So I'm going to go ahead and put times 40. Okay? Now if you choose, you can go ahead and multiply that right off the bat. And if you want to call that 8.4, you can. It doesn't matter. So now if you're thinking about overall in terms of solving this equation, in this case I probably would use substitution to solve. And the primary reason is back here at this guy right here, I can go ahead and solve for X or Y, and it's a pretty easy do. So if I'm thinking about this, I could say Y equals negative X plus 40, and then take that and plug it in here and start solving it. Okay, so I'd probably use substitution in this case. Again, elimination's fine. You'll just have to multiply either by the 0.15 or the 0.33. All right, so now let's go down and look at example 2. Gunther invested $10,000 in 2 mutual funds. One of the funds rose 6% in 1 year, and the other rose 9% in 1 year. If Gunther's investment rose a total of $684 in 1 year, how much did he invest in, that should be in, sorry, each mutual fund? Okay, so now I'm going to start by defining my variables. So I'm going to have X equals amount in the 6% fund, and Y is going to be my amount in the 9% fund. Okay? All right, so I'm coming back up here. I know that I've invested a total of $10,000. So my first equation here is going to be X plus Y equals 10,000. So I'm taking how much I put into each account, and it should equal $10,000. Now again, just like we talked about in the last one, keeping your percents together. So I've got 6%, 9%. And in this case, I don't have a percent for the total, but what I do have is a total of how much those percentages earned me, okay? So when we write this, I'm going to have 0.06 x plus 0.09 y equals $684. And then again, in this case, I would go ahead and probably use substitution again. I would take the top equation here, and I would have like y equals negative x plus 10,000. And again, I would go ahead and substitute that in there. Now, you may use elimination if you choose, but that's up to you. All right, and the last problem we're going to look at today, it says Wyatt wants to mix raisins worth $1.60 per pound with nuts worth $2.45 per pound to make 17 pounds of a mixture worth $2 per pound. How many pounds of raisins and how many pounds of nuts should he use? So the first thing we're going to do is define a variable. And so I'm going to go ahead and use R for pounds of raisins. And I'm going to go ahead and use, oh, not Y. Let's not use Y. Let's use N for pounds of nuts. Okay. All right. So the first thing I'm kind of looking at here is I have a total of 17 pounds. And again, I have R pounds of raisins and N pounds of nuts. So I'm going to take that R plus N, and that's going to get me a total of 17 pounds. Now I'm going to go ahead and I'm going to take a look at my money. I've got $1.60 per pound, $2.45 per pound, and then $2 per pound. Okay, so since I have $1.60 per pound of raisins, I'm going to put R because I don't know how many raisins, plus $2.45 times the pound of nuts equals, and I've got 2 pounds. Now in this case, I actually do know how many pounds of the mixture I have. I have 17 pounds, so I am going to put that right here. So I'm going to have 2 times 17, or if you choose, again, just like in the first example, and you want to put 34, that's fine. So now, again, you could use substitution, elimination. I'd probably use substitution again, but elimination is fine as well, where you can multiply the top either by 1.6 or 2.45. All right, and that concludes our lesson on setting up mixture problems.